So I'm attempting to draw the free body diagram of the turtle. There is a downward pull on the turtle by the earth with a force of m1g, where m is the mass of the turtle, maybe mtg, and then the elevator applies a force on the turtle in the upward direction, because an elevator can only push, it cannot pull. So these are the two forces that act on the turtle from outside. So we have the F external forces in place, and that will be equal to, according to Newton's equation of motion, the total external force, which is going to be N, which is positive. And remember that the observer is on the ground, and this is the coordinate system, and the upward force is positive, so minus m1g is equal to m1 into acceleration as it appears to the eyes of the observer. And as far as the observer observing from the ground, the turtle and the elevator are moving up with an acceleration a. So this is the acceleration of the turtle as it appears to the eyes of this observer, and therefore he says that the force, which is n minus m1g, is equal to mass into acceleration. Now the prediction of Newton's equation for this problem now is going to be that n is equal to m1 into a plus g. So the normal force is now higher than the weight, and we say that there is a gain in weight when the lift is moving up with an acceleration a. So one can easily guess that the equation will change if the acceleration is now in the downward direction a, then in that case it's going to be n, which is always going to be positive because the lift can only push, minus m1g, which will always be negative because the gravity is in the downward direction. But this time the acceleration a will get a negative sign because a is now in the downward direction as per this coordinate system, and therefore now we get n is equal to m1 into g minus a, and this is called a weight loss. And one can easily imagine the extreme case when a